How's it going, everybody? This is Pete the Bush. Today I'm going to review this low-cost Oria Digital Clamp Multimeter. This thing runs about $24 only. And if you know about digital multimeters, if you just go try to buy the professional ones, it's going to cost anywhere from $100, $200, $500 even. So if you're just trying to look for some basic functionality for something to use around the house, to check batteries, to check how much current's going through things, then this thing might be a very cost-effective way to get a multimeter, get the functionality, and not break the bank. So now I'm gonna unbox this device and show you what's inside. And then I'm gonna test out the functionality and compare it to more professional grade digital multimeters, basically so you can know what you're missing out on when you go from a very expensive digital multimeter to something a lot cheaper like this one. It comes in this box, model number OHA51. Accurately measures AC current, AC-DC voltage, resistance, diode, and continuity test. There's no DC current in this meter. Digital clamp multimeter says read the manual, follow all safety information, accuracy specification. It's made in China, just like many things. Same thing on the other side. Nothing else on the inside. It comes in this case, and it seems like a lot of low-priced China-made products comes with cases and a lot of little accessories. Maybe it's a way to get you to try to buy their product. Anyway, the clamp is right here. Comes with the test leads, manual, and this little hand strap thing. This thing goes right here. Manual, we don't need that. Unwind it, plug it in. Let's test out the resistance part of this meter first. I have a 680 ohm resistor right here. And in order to really accurately figure out what the resistance is, I want to find out what the resistance of the leads are. So I'm gonna put these together like this, touch them together. And after a while, it says 0.1 ohms. Okay. And then I'm gonna put the little resistor on top of here. It says 681 ohm. So then if I subtract the resistance of the leads, it's 680 ohms. Now for this one, it's a fluke. This one costs a lot more, 100 something dollars. So if I put these together, it goes 0.2 ohms. The response rate is slightly faster on here. And if I just touch them together like this, it needs to make good contact with the leads. 682 over here. So, you know, both can measure 680, but I'm not too sure about the long-term accuracy of this thing. As you own these things, they might drift a little bit, but for home use, you really don't need it all that much accurate. And if you change it to the voltage, right, then you might do something like this where you measure the voltage of these batteries. And if you know the chemistry of these things and you know 1.6 volts or so, it means it's fully charged, or 1.5 is pretty highly charged already. This one has a 0.7 volts, which means this is dead. So basically I'm just gonna put this somewhere and recycle those guys. This one over here, 1.36. So I'd say, I think this is about like, you know, 50% charge still. You can still use this battery, although it's a little bit low. Next, I want to highlight the continuity feature of this thing. You just go to the diode and then you press select. And whenever you connect these leads together, it's gonna beep. That means there's an electrical connection from this point to this point. So this is useful for if you want to test if there's a wire connection somewhere. You don't want things to be powered on when you do this test. So if I touch here to here, you know, oh, something is electrically connected. So you can test out cables and things to see if it's fully connected. But the thing I noticed about this low-cost meter is that the response rate is slightly, just a little bit lower. It takes about a split second or 0.7, 0.8 seconds before it registers. See? If I just tap it, it does not beep. If I tap it too quickly, it does not beep. But if I give it just enough time, I'd say it's about 0.7, 0.8 seconds or something, just out of the top of my head. On this Fluke very expensive one, you just go to the continuity tester and check this out. It's almost instantaneous when it beeps. This is about as fast as it goes, I think. But this one, if I do the same thing, see, it does not beep. So this is useful if you're gonna do a lot of continuity testing. If you have like a really huge board and you wanna test like 20 connections and you just go da, 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 and it's gonna make your life easier and faster. But if you're just doing simple things, it's okay to you know, take like 1 second longer, half a second longer. You'd hardly notice the difference. But this is the difference between you know, this is about $24 right now on Amazon versus I think this one is close to $124. Next, I have all these interesting gizmos to show you, mainly to test out this AC amperage thingy. Now, in order to test this out, you need access to one of the lines of the AC line. Now, this is not a usual thing where a normal person would have access to unless you're like cutting up wires and stuff. But I have this little power adapter here, a kilowatt, which measures the amperage. Now I have this cool little AC line voltage tester. It allows me to plug something in and have access to one of the power AC lines here without needing to cut the cable or anything. This is a lot safer. So over here is a kilowatt and I have a power adapter here so I can show you the power under the camera here. Right over here it says 123.9 volts. I'm gonna plug the light in like this, and then in order to see how many watts this thing is consuming, it says 10.8 watts. Now the light bulb is warming up, so then it's consuming more and more as it brightens. So I plug this in and I plug this other side in like this, and we'll let that light bulb warm up a little bit. And now we can go ahead and test this amperage thing. Now this little gizmo here has one AC line coming over here and one AC line going over here. If you clamp onto the AC line just like this, you're not gonna read anything because some current is going this way and some current is going that way at any instant of time, so it's gonna cancel each other out, so you read 0 amps. So this little gizmo over here allows one wire of the AC line to come here, one line go over here, so then I can put this little clampy thing around, and this is 1x reading. It shows 0.101 amps. If I multiply by the voltage shown here, 123.8 by 0.1, it's basically 12.3 watts, and this is what this kilowatt measures, 12.3 right now. It's rising to 13 watts, and I can turn it up to the 400 amp rating here, which is quite a lot for anything, and it's still gonna read, I guess it doesn't register it because it's in the high setting. It's supposed to show 0.1 over here, but it might be too low. Let me switch it back over here. I can go to the 10x version here, which will really show 1.0. Generally for the high amperage rating, it's likely not going to have as much accuracy as the lower one. So you generally want to pick the lowest one that you can without going over. So I'm going to do the 20 amp here, and then now it shows 1.13 amps AC. If I click max here, it's just going to take the maximum all the time. If I push hold, it's just going to show this number, and you know, it's gonna take new readings or whatever. I can take it out and I go, okay, yeah, it's gonna show 1.136 amps. It's really not 1.136 because it's 10x using this hole over here versus this bottom hole. Lastly, let's compare the voltage reading of this kilowatt. It says 123.3 versus what this thing says, 122.5. So close enough to me. I mean, you're gonna be able to use this thing for household things. If you have, you know, appliances where you have access to one of the AC line, you want to measure how much it's consuming, you can do that with this little clippy thing. This operates by magnetic fields, by the way. That's why if one wire goes through, there's magnetic fields going around it, and it induces a current in this loop here. That's why it has to be this loop. See, when you open this up, it has this little metal part here, and on the other side there's like a little metal piece here. When you click it together, there's a connection that goes in a loop like this, and that's how this thing measures it. So thanks for watching this review. I hope you gained an understanding of how to pick a digital multimeter for your needs. If you're interested in this particular digital multimeter, don't forget to check out my affiliate link down in the video description below, where I'll link this product, and you'll help out this channel if you buy it through this link. If you're interested in supporting this channel, don't forget to check out my Audible link down in the video description below, where you can get a free audiobook. I have a Patreon over here, and don't forget to subscribe. Thanks for watching.